The counting circuit is able to count from 1 to 9 before it rolls back over to 0. It is also able to count backwards. The NAND gate oscillator uses the pull-up resistor configuration. The NAND gate oscillator creates a square wave with a frequency and duration. As you can see, the LED is flashing on and off. It's going on for the highs in the square wave and off for the lows. After the duration runs out, the tactile push button must be pressed again for the duration to be reset. The 4017 Decade Counter chip is able to power a 10-segment bar graph display, with each of its outputs triggering one after the other, and the red LED is connected to the divide by 10 pin. The 4510 chip converts the divide by 10 output from the decade counter into a binary base 2 numbering system. As you can see, the LEDs are shifting between numbers 0 to 9, and the switch makes the numbering system reverse direction. The 4511 chip takes in the binary numbering system from the 4510 chip and converts it into human readable form through the output pins on the top of it and sends them to the 7-segment display. There must be resistors between the 4511 chip and the 7-segment display, otherwise the display will burn. The PCB version of the counting circuit has an on and off switch, which when flipped on allows it to be activated. To activate it, press down the tactile push button. It will begin to count up. It has two 10 kilo ohm fixed resistors, two 1 mega ohm fixed resistors, one 470 ohm fixed resistor, one 0.1 microfarad capacitor, and one 100 microfarad capacitor. It also has an additional slide switch, which you can slide down to start counting down instead of up. And every chip used earlier in the breadboard prototypes is used here. The dual-digit counting circuit is able to count from 00 to 9.9. And once it reaches 9.9, it will roll it back over to 0. As you can see here, when the tactile push button is pressed, it will begin to count. And it will count until 9.9 before it rolls over.